Satellites then. Any object that orbits another object is a satellite. So the Earth going around the Sun makes the Earth a satellite of the Sun. The Moon going around the Earth makes the Moon a satellite of the Earth. In this section, we're just talking about artificial satellites. So we're talking about objects that we have put in orbit around the Earth. And there are two kinds of orbits we're going to think about. One is a geostationary or geosynchronous orbit, and the other is a low polar orbit. So let's look at those then. Firstly, why do they orbit in the first place? Well, these satellites are all performing circles around the Earth. Now, if you look at this satellite here, at this point, its velocity is this way. And if there wasn't a force to cause that velocity to change the direction of it, then it would just keep going in this direction. Because as you know from Newton's laws of motion, if there is no resultant force, there is no change in motion. Now, because this motion is changing, it's going from going in this direction to over here, going in this direction, and then over here, going in this direction, then there must be a resultant force causing the satellite to change its motion. So that's why it performs the circle, because there is a pull inwards from the Earth due to gravity, making the satellite perform the circle. If the Earth was to suddenly vanish, then this satellite here would carry on along this straight line. So it is because the satellite has a pull towards the center of this circle due to the Earth in the center of the circle. That's why it performs the circle. Without that pull, it would just perform a straight line. So low polar orbit satellites. These are for monitoring. Like it sounds, they're not very high. You might say, 200 to 1,000 kilometers is high, but when we come to geostationary orbits, you'll see that's really quite low in comparison. So they are low. They go over the poles or thereabouts. So you can see that as the satellite goes over the top there, the Earth is rotating underneath it. And so the satellite is able to scan the entire Earth. The satellite will go over, will perform an orbit many times during the day. So the satellite is able to scan the entire surface of the Earth. So if it has infrared cameras on board, then it can check for early warning for forest fires, for example. So if you have some great expanse of the forest, like the Amazon, where nobody lives, or there's no easy communication at least, the satellite can spot a forest fire beginning long before anybody's going to come across it and take action or get others to take action to deal with that. They're used for weather forecasting, weather monitoring. They're used for spy satellites. So nations are using satellites to look at other nations. Geostationary satellites then, like it sounds, they appear to be stationary relative to the Earth. They're not stationary, of course, they are orbiting. But if you look at the animation, you can see that this satellite is staying over the same part of the Earth's surface. As the satellite rotates, the Earth rotates, and so the satellite is over the same part of the Earth all the time. That's with a geostationary, or geosynchronous, where it is synchronized with the Earth's rotation on its axis. These are over the equator. It's the only place you can put a geostationary satellite, over the equator, so that the pull is always horizontal, if you like. So you can see that as you change the height of the satellite, you change the orbital speed, and so these satellites are exactly 35.9 thousand kilometers above the Earth's surface. Compare that to the low polar orbit, 200 to 1,000 kilometers. You can see why low polar is called low polar. Much lower altitude than the geostationary satellites. So The ground station on the left sends a signal up to the satellite then sends a signal back down, and this satellite is always available to this ground station, so 24/7 signals can bounce up to the satellite and back down again. So you've always got Sky TV, you've always got telephone communication, you've always got this ability to send computer data and receive computer data over long distances. So that's what they do. You'll recall from your work on the electromagnetic spectrum that it is microwaves that we use for this, and that's satellites.